All right, so as we're looking at 9-6, direct variation is, again, if I were to make $15 an hour and I worked for 3 hours, then I would have made $45. So it's just a proportion. Let me give you this example. If I said if y is 15 and x is 3, I'm going to say find y when x is 12. I don't know why Mr. Richards didn't write that example down, but this is our little example that we're going to do to practice this equation. And the words I'm not having you write down is y varies directly with x. I didn't have you write that down because we're going to use this formula. Any ideas how we could use this info first? We're going to plug my 15 in for y and my 3 in for x just to find my k. Then I'm going to plug that k into this information. So let's go try that. Do you agree if y equals kx, it'd be 15 equals 3k or k3? Yeah. How would I get k? And what would k equal? Cool. K is 5. So now I'm going to use that over here when it says find y when x is 12. So I'm going to go back to that same equation. I'm going to say find y. Okay, so y equals, I know what my k is now. What did we say it was? 5. And I'm going to use 12 for my x. So I'd have 5 times 12.
60.
Yeah. Why can't I write? 5 times 12, and I get 60. That's just direct variation. Again, using these proportions. All right, let's go do inverse. So if you're direct, you multiply k and x. If it's inverse, we just divide them. So an inverse variation is y equals k divided by x. So this is this guy's formula. This is this guy's formula. K over x. Let me give you another example. Again, if they say y it varies inversely with x. Here's the info I'm going to give you. I'm going to say y is 5, x is 10. Then I'm going to say find y when x is 2. So first, let's just use this info right here. What am I going to put where?
You're going to put 5 in place y.
Yep.
Yeah,
so I got k over 10. What's k going to be? I heard it. 50 is my k. Agreed. You guys, I'm going to go plug that in right over here. Same equation. Find y if x is 2. Yeah, he says, okay. Then I'm going to say y is my k, which I just found was 50, divided by my x, which they say is 2. 50 over 2?
25.
We got it. Joint variation just gets more variables involved. So joint variation is y equals kxz. So that guy goes with that. And again, it's just the same kind of topic. If y varies jointly with x and z, let me give you some numbers. I'm going to say if y is 80, when x is 5, and z is 8. Let's just focus on that first. Let's go find k. What goes where? What am I going to put in for my y? 80 equals, I don't know my k. What am I putting in for x?
5.
And my z? Cool. What would we do to get k?
Multiply the parentheses. So you get 40.
40 is right there. Then what would you do with that? So I'd have 40k.
Then divide by that.
Yeah, divide by that 40. And what would we get for k? Perfect. Okay, so knowing this info, I'm going to give us a little bit more. It's going to say find y. So the last part is find y when given x is 16 and z is 2. That's a 2. I'm going to go back to that formula. Find y. So I'm going to say IQ. Y is. What's my k?
2.
Good, because we found it back there. My k is 2. My x.
16.
My z.
2.
Multiply them together. What'd you get?
64.
Me too. Let's go back to this now. Changing repeated decimals to fractions without our calculator. Anyone know what 0.333333 is going to be? What is 0.333 as a fraction? 1/3, I agree. What if you didn't know that memorized thing? Let me show you. This is kind of cool. I agree it's going to be 1/3. And if there's one like this that you know the answer to, great, you can just jump to it. I'm going to show us mathematically if you don't. Does anyone know what this one is? 2/9. I agree. What about this one? It's actually 57/99. And how would we know that, right? Here's our trick on how to do it. You guys, what we're going to do is we're going to first just say, all right, X is the decimal that they gave me, 0.3333. I'm going to just write that out. I typically do 4 decimals. And what I want you to do with that now is go ahead and let's multiply both sides by 10. If I multiplied this by 10, what would I get? 10x, okay. What about 3.33333 times 10? 3.333, agreed. So what I meant to have you do is actually write this part underneath it. So let's just draw ourselves a little note. Let's just say, I'm going to bring that down. X equals 0.333. Okay. I need these to match. My bad. So after that decimal, I want to have the same amount of 3's after my decimal there as I do there. But that doesn't make sense because if I multiply by 3, so I'm actually going to do that. I'm going to bring that 4th one down. So here's what I want us to do. Go ahead and subtract these two now. What is 10x minus 1x? 9x equals just 3. Exactly. That's what I needed. So I should have just made this. This is my bad, you guys. I'm sorry. Because if I said x was 0.333, yeah. 3 I'm sorry. Wouldn't we just get 3.333 minus 0.333? That would just get me 3.
Yeah.
You agree with that?
Yeah.
Then what would I do to get x by itself? What is 3/9 the same as? Done. That is the value of that decimal as a fraction. Whew, I did not do a good job explaining that, so let's try that one more time, shall we? Okay, I got you, people. Here's what I want you to do. I want you to put right under here what x is. X is, how many decimals do we want to do? I just did 3. So let's do 0.222. Notice I left some space here because above that, I want you to multiply this by 10. 10 on the left is going to get me 10x. What about times 10 on the right? 2.22, and I'm actually going to have those decimals always match, okay? Because this guy's going on forever. Then what we do is we subtract. 2.222 minus 0.222 would leave us with how much? 9x equals 2. Thank you. Divide by 9. Guess what, Roman? You said 5 minutes ago, 0.222 is 2/9. How does it change when I've got 0.57575757? Well, you guys, I'm going to have you write down here that x is 0.57. Let's go 57. Let's do 4 decimals. And for those decimals to match and cancel out like they've been doing for us here, if I only multiplied this by 10, it'd be 5.757575. But so what I want you to do, does anyone remember this is the 10ths decimal and this is the 100ths decimal place? So we're going to multiply this by 100 exactly. So if I multiply x times 100, I'd have 100x. If I multiply 0.5757 by 100, I'm just going to move that decimal to the right too. So I'd have 57.5757. Let me say that one more time. This decimal, I give us 4 off the end. By multiplying by 100, that moves that decimal to the right too. 57.5757. I always want this extra decimal to match that one. So when I do subtract them, 100 minus 1 gets me 99 equals 57. Oops, I forgot my x. Therefore, x equals, good job, you guys. Who would have thunk? What the heck does this little factorial mean? Here's what it is. Anything with a factorial, it doesn't mean that I say this like this. 5! Like 5 with an exclamation point. No, it means 5 factorial, which means you take 5 times 4 times 3 times 2 times 1. Now, you're like, dude, I don't want to do that. Is there a button on my calculator? Sure is. Everybody get that calculator out. Let me show you. Everybody go hit 5. Anyone know where it is? Yeah, how do you get to prob, though? Math. Where he said prob, you see on the top, PRB, you got to use the right arrow until you're in probability. Then do you see an exclamation point? Option 4. Look at that. It looks like 5. Hit enter. And all that does is it takes 5 times 4 times 3 times 2 times 1, and it does it for us. We like that. So you never have to write that out. You can just say math, probability, exclamation point. It's just 120. 5 times 4 times 3 times 2 times 1. How about B? Could we go type that in my calculator? Yeah. Sure. I'm going to do 7 math probability 4. Oh, now I got an add. Over 5 math probability. I got 42. But I want to show you, what if we didn't, ACT would not give you your calculator for that question. So I want to show you how we would handle that without a calc. Do you agree 7 factorial, or 7? It's like this. 7 times 6 times 5 times 4 times 3 times 2 times 1. What's 5 factorial if I were to write that out? 5 times 4 times 3 times 2 times 1. Would anything cancel out? Ones, twos, threes, fours, and fives. What am I left with? Is 42. So that's what ACT would do without a calculator. But wait a minute. You get a calculator on the ACT, so maybe SAT. That's a good point. And maybe if they did huge numbers, like we'll kind of see down here, it might save us time to not have to type it into a calculator. It's up to you, but I just want to show you the skill. So before we type C into our calculator, let's try it by hand. What would I have up top if I wrote that out? Thanks so much. On the bottom, what's 5 factorial going to write out to be? Yeah. What about 3 factorial? Thanks. So I wrote those in all different colors just so we could see. I just expanded them out individually. Does anything cancel?
The ones, the twos.
Ones, twos, threes. Does anything else?
4 and 5.
Yeah, so could I have done any of them? I could have done 1, 2, 3, 4, 5. It doesn't matter. What do I have left up top? 8 times 7 times 6, which I would just use my calculator. So if we're using our calculator, maybe we would have just typed it in the whole time anyway. And I would have had 336 over 3 times 2 times 1? 6. 336 divided by 6 got me at 56. Who's already typed that in? And you're like, dude, I was there 3 minutes ago without doing all that slop. I'm fine with it. What happens, though, when I don't have just a number? What happens when I have a variable? Well, you guys, x plus 3 yeah.
Would you put the parentheses around the second one on the bottom one or no?
Oh, down here, buddy?
Yeah.
Are you saying that this should be like that?
Yeah.
Yeah, you can. With multiplication, I'm going to have you guys just practice this one on your own by using that inverse variation formula. Go for it. Anyone else get that? Did I do that wrong? I did it wrong. I got to erase all mine. What's 96 divided by 4? 24, duh. Did anyone else get 24 or did I lose you? Okay. This one was a little different because on this one I asked what is x, not y.